Hello, everyone. Thank you so much for joining us for today's WiCyS webinar. My name is Morgan Garland. I am the board liaison with Women in Cybersecurity. And with me today, I have Sharon from Google, who's going to be leading the webinar. Before we get started, though, I just wanted to share a few slides of the WiCyS organization for those of you who are not familiar with us. WiCyS is a 501c3 nonprofit with a global reach dedicated to bringing together women in cybersecurity from academia, research, and industry with a mission to recruit, retain, and advance women in cybersecurity. We often go by our acronym WiCyS, as in We Sisters, because that is exactly what we are. We're a global cyber sisterhood. We have over 11,000 members in 107 countries. We have 68 professional affiliates and over 300 student chapters around the world. We offer a wide range of initiatives throughout the year for all career levels. Some of our current initiatives, you'll be receiving our monthly newsletter here shortly. If you're subscribed to our mailing list, we have our annual conference, which will be coming up in March of 2026, the 11th to the 13th. We hope to see some of you there. We also have our job board that's open 24/7 year-round for all of our members to access job postings from our strategic partners. You can view a list of all of our current programs that are available on the WiCyS program page on our website at WiCyS.org. Some current programs that we have right now that are accepting applications is the Aspiring Mentorship Program. We have the Executive Leaders Network, CN Cyber Range, the VDP program, and our book club that happens every month. And we owe all of our wonderful initiatives to our strategic partners, our tier 1 partners being Akamai, Amazon, Bloomberg, Cisco, Ford, Google, Lockheed Martin, Optum, Palo Alto Networks, SANS, and SentinelOne. And please ask questions today. You'll see a box on your screen that you can drop your questions into. We do have time reserved at the end of the webinar for a Q&A session. So if we don't get to them during the presentation, just know that they'll be answered at the end. And lastly, if you are not already subscribed to our WiCyS newsletter, please subscribe to our mailing list to receive communications on all of our upcoming events, initiatives, and programs. You can join at WiCyS.org. And with that, I'm going to turn it over to Sharon to start us off with today's webinar. Thank you, Sharon.
Thank you so much. And thanks to all of you for joining. It's such a pleasure to be here for everyone at WiCyS. I'm Sharon Crew, and I'm a technical program manager working in Google Cloud CISO security engineering. My journey to cybersecurity has not been a direct path. I worked for many years at financial companies specializing in infrastructure capacity and data analytics. And I joined Google over 3 years ago and worked in multiple teams as a technical program manager, leading the execution of security programs. My current role is managing programs to drive down security risk for our Google Cloud products. Today, I want to talk to you about the problem that plagues every security team, regardless of size, the sheer volume of data. We're very good at finding vulnerabilities, and often we're drowning in them. It's sometimes a game of whack-a-mole. We fix one issue, and then another pops up. What we really need is data insights. So for the next 30 minutes or so, I'm going to show how we at Google are using large language models to make sense of the chaos and classify security risks at scale. Here's the roadmap for today. We're going to start by defining what risk insights is and why it's so critical. Then we'll look at specifically why we chose large language models to solve the classification problem. And then I'll walk you through a real-world use case we're tackling. We'll get to which is the core of the presentation. Most importantly, I want to share the hard lessons we learned along the way, the things that went wrong, and how we fixed them, so that you can build this effectively in your own organizations. Okay, let's go. Okay, what is risk insights? So broadly, we're not talking about a spreadsheet of bugs. It's risks with broader themes and patterns and clusters. And why is it so important? Because raw data doesn't drive change, insights do. Good risks Good risk insights inform our strategic planning, telling us where to put our money and our people, and they drive remediation efforts by pointing us to root causes rather than just the symptoms. And ultimately, they elevate the security posture of the entire product line. We need to move from fixing bugs to fixing classes of bugs. Why did we use LLM to help classify these risks? Well, here's the picture on the top right. That's the problem we face. A lot of security data comes in from different sources like scanners or bug bounty reports, pen tests, internal audits, you name it, and none of it's normalized. One tool might say XSS, another cross-site scripting, or a third might say input validation error, etc. Historically, we relied on manual classification to sort this out, but manual classification is hard, costly, and very tedious. Worst of all, humans are not so consistent. Even experts disagree. If we give the same vulnerability to 3 different people in this room, I might get 3 different classifications. When you try to scale that across thousands of findings and risks, you end up with data you can't totally trust. This is why we turn to LLMs. We need to untangle this mess with a level of consistency and scale that humans simply cannot sustain. When we talk about classification, we aren't just putting things into one big bucket. We are looking at specific multidimensional use cases. Some are connected to security and some are not. For instance, since we support cloud products, we need to have visibility to categorize by product name to see where the issues are concentrated. This is not simple or out of the box, as the sources often don't contain product name and the product catalog is often changing. Then we also can classify against high risk classifications or categories like authentication, authorization, supply chain. These are very useful for executive reporting. But if we want to dig a little deeper to really understand more of the root cause, we then looked at the CW25 root cause, which is a list that MITRE comes up with on the 25 most dangerous software vulnerabilities. For instance, out-of-bounds read, write, missing authorization, hard-coded credentials. This is one level deeper, but it only contains 25 and is limited to software vulnerabilities. So then we then looked at a new categorization called invariance. And this is a North Star principle of where we should aim as a cloud organization to go to. And we specifically looked at issues related to cloud, like secure by default, multi-tenancy, for instance, when to have untrusted workloads isolated, and secure build pipelines. The beauty, finally, we also have around multi-tenancy classification and top risks. And top risks are something that we defined as an organization ourselves. And we say, how does this look across our cloud product landscape? The beauty of this approach is that we can take one unstructured risk and drop it into all these buckets simultaneously. And it gives us a rich multidimensional view of our security posture that we never had before. So how do we do this? So this is a process we developed after trial and error, of course, and we find that this is the best way of doing this. The first step is to outline the use case, the classification use case. For instance, I had many different classifications in the previous slide, and we had to really understand what value will this classification give us. So that's really important to start with the problem you're trying to solve. And then you develop an initial prompt. The initial prompt is something that defines each of the classes and also perhaps gives some examples to help it set the context properly. But of course, you're going to have to iterate on that prompt. But what that initial prompt also gives you is a sample set for ground truth collection. So ground truth is a gold set of data. This is risks that are curated by security experts to help us measure the LLM performance. So each sample is rated by at least 2 security experts. And if those experts disagree, we bring in a third expert as an arbiter to resolve the conflict. We don't proceed until we have human consensus. Then what we're looking at is to understand the accuracy of the prompt. So once we have ground truth, we could run the prompt and against a model and see what the accuracy is. So we collect accuracy, precision, and recall. This is a continuation of the first slide, but once we have the accuracy, is it acceptable? Is it good enough? It doesn't have to be perfect, but it could be good enough. If the answer is no, then we have to iterate on the prompt. And more often than not, you have to iterate 5 or 6 or 7 times to get a acceptable accuracy. And what acceptable is up to you. If you feel like 70% accuracy is acceptable, that's fine. If it has to be 95% or 99%, that's fine as well. So we just have to make adjustments to the prompt, perhaps adjustments in other ways, and to tweak the results to make sure it's better accuracy. Once we accept the accuracy and we say this is good, we're going to push it to production pipeline, and the job's not done at that point. We have to continuously monitor for quality. So again, measuring if there's any performance drift for accuracy with new risks coming in. And like I mentioned at the bottom, iterating on prompts will improve the accuracy. So iterate, iterate, iterate. So that's our process. Let's see what we learned. One thing we learned, which was difficult, was that you just can't assume that your security experts will align. And we put 5 experts in a room, and they were all arguing about the different classification. So the way we improved this was we developed a playbook, and this way we defined exactly how the raters for the ground truth would say this is this class or this is another class, and this really improved consistency. The other part that's very important is when we take a sampling for ground truth, we should take across different classes. So if it's too much in one class and not enough in another, then the accuracy won't be as good for the ones that we didn't sample enough of. And that's really important. So we should take, I'm not sure exactly the number, that's up to you, but take a bunch from each class. Now, of course, if you have a lot of classes, it's more difficult, right? So there's other things you could do at that point. Thirdly, we want to monitor inter-rater agreement. So if humans only agree 60% of the time, then your AI won't improve on that. So you want to really drive the consensus across your experts. And often when you do have these inter-rater discussions, you really uncover whether there's a gap in the prompt, and also, or whether the rater has a comprehension gap. So often those are really very insightful, and we then go back often to improve the prompt or to explain the rating a little better in the playbook. As I mentioned before, we really want to make sure all the experts agree, because if the experts can't agree, then how can we expect the LLM to figure it out? So if there's no agreement at all, then we might take a different sample. Okay, so that was with ground truth. So this is with model selection. So this was done over the last year or so. So things have been changing very rapidly. But what we did find is there's a setting when you use LLM models called temperature. So temperature equals 0 is an ideal setting for using for classification. It tries to ensure a more deterministic and consistent answer, because we're not writing poetry or being creative here. We want to have a class of risk, which we want to make it a little more deterministic. And if we run that prompt over and over and over again, are we still getting the same classification? And that's temperature equals 0 will help with that. Second, we highly recommend thinking models, models that are trained to have reason before they answer. And this really, first of all, it shows you the chain of thought. It shows you all the details of how it got to the to the classification as well. You should output that reasoning so that you can understand it a little better. But that it definitely showing the reasoning and having thinking models upped our accuracy significantly. Third, and this was a little bit because just from experimentation, we discovered that multi-label classification is better than binary classification. So multi-label is when you have a list of different classes, let's say a list of CW25, and you could select multiple of those. And binary, if you had binary, it wasn't as accurate. So we discovered that that's the case because classification of security is often, there could be many correct answers or multiple correct answers, usually not more than 2 or 3. But also when doing multi-label classification, we included all the classes in the prompt, and that gives it better context. So it's less of a vacuum, whereas binary classification is this a multi-tenancy issue, yes or no? So it might not understand all the other choices as well. Also, we had hallucinations, which is common with AI, but we did fix them quite well by enforcing structured output. So rather than having the output be like a paragraph, okay, or something more loosely structured, we had it output a JSON with specific classes, so it could not choose a new type of class that we didn't know about. So that was very helpful for hallucinations. Then we learned a lot about prompt engineering and how this could work when you work with when you want to tweak the prompts. One of the main things that was difficult at the beginning was that the LLMs was getting confused over whether we wanted the trigger of the security risk or whether the root cause. And even humans were confused about that. So we had to very explicitly say we are interested in the root cause, because the root cause is something that's more actionable. So for instance, we might have a scanner come and say it's information disclosure, right? If sensitive data is visible, but that's a symptom. That doesn't mean that, that really there's nothing actionable about that. But if we want to see the root cause, it was hard-coded credentials or misconfigured access control list. That helps you figure out what the next steps are and make it more actionable. And so we had to really explicitly put that in the prompt. And once we did it and gave examples, that really helped the quality. We had some classes that were abstract or overlapping, and that was a problem. So we had to redefine them very carefully and give examples. For instance, the secure by default, it is a little bit abstract. Like, what does that actually mean? So so we put in multiple examples, and we made sure that the classes were as distinct as possible. Then, as we did measure accuracy, there are 2 other measurements that we did, which was precision and recall. So precision is like do you trust this data, right? So if it says, if the LLM comes back and says this is of risk of class X, is it right? Or how often is it right? So if precision is low, then there's a problem with false positive. We're getting things that aren't correct. Recall is about safety. So if out of all the risks of class X, how many did the model find, right? How many were found? So recall is about false negatives. So did it not find all the risks that are supposed to go into class X? And that is really more important in some ways for security, because you don't want to miss something. But what these measures give you is, and these are mathematical formulas, but what these measures give you is how to tweak the prompt. So if there's a lot of false positives for a specific class, you could then give examples of true positives, right? And if there's a lot of false negatives for a certain class, you can again give true negative examples. Okay. Now then what we also did was we tightened the classifications with detailed lists. So as much context and detail we found that was really helpful. But so it's a matter of iterating. It's just a matter of trying something, getting a sampling for ground truth, measuring accuracy and precision recall, and then going back and tweaking and iterating until you're comfortable with the accuracy. So to wrap things up a little bit, LLMs, we did find them to be more consistent and more accurate than people. But it took some work, right? So, and now with even newer models, I think that will even improve a little bit more. But we did find it scientifically with actual measurements that this was a more accurate way of classifying a large amount of risks. And it does improve risk analysis. It's not perfect, but we're able to automate it at scale, and we would never have been able to do this. So there is, real use cases here and real path to adoption, but there's a little bit of a but there that I wanted to share with you. I think the image is blocking some of it, but basically, really you have to have a clear taxonomy. So if you have taxonomy, let's say you have a top risks taxonomy, you want to make sure that those risks are very clear and not overlapping. So that really, really helps. And that took some time for us to do, to be honest. The ground truth was the trickiest part of this exercise. The automating of collecting of ground truth at scale is the hardest challenge for us, but it is an important part of a very important part of the process, because we need it to measure our performance of the LLMs. Okay, so thank you very much. Today we talked about the problem of noise and how security teams are drowning in non-normalized data, and how we can use LLMs to turn the chaos into actionable risk insights. We walked through the classification process. We started not with the model, but with a clear use case and rigorous ground truth collection and rating. And it's not about the prompt, it's about the process, verifying that the data with the experts and measuring it strictly with precision and recall. We shared some lessons learned around model and prompt tweaking. And the final thought I wanted to leave you with is that LLMs are very powerful, but they're not magic. If your taxonomy is messy, the model will just reflect it. But if you work to drive toward quality and accuracy, and you define ground truth, um, and you'll build something that not just classifies and categorizes vulnerabilities, but will also change how your organization understands security risk. Thank you so much for your time today. I see we have a lot of time, so I'm happy to take any questions. And I see there are some in here. Okay, there's one question from Ravi. Thank you. Can LLMs really be consistent, even being non-deterministic? Very good question. I mean, we did work a lot on having it to be as deterministic as possible, but you are right. By design or by definition, LLMs are not deterministic. We can have settings like temperature equals 0, and that helps with the deterministic part of it. The other part that is really important is the prompting. So using very strong the output, constraining the output is helpful as well for hallucination, but making sure we have the same output time after time after time, that is, a lot of it is in the prompt itself. So I would say three things. One is temperature equals 0. That's the setting I would use, and often it's not a default setting. Then use the prompt to make sure that it's very clear and the output requirements are very clear. And then as well, the taxonomy being clear, that it definitely helps. So if there's an unclear taxonomy, you're going to get a lot of different answers. And then constraining the output will help as well. So three-pronged approach, but you're right. Out of the box, it's not deterministic at all. But I think with those three things, you could control it. Okay. Next question by Sadie. Thank you. Is this insight specifically only to multimodal models or only LLMs? And for servers, okay, so I'll answer that one first. We did not use multimodal at all because our data sources were text-based. So from scanners, other, some manual reports, so it was all text-based. So it wasn't multimodal. It's just, when we started, we used a very old Gemini model. Currently, we're way more advanced. But so hopefully the accuracy goes up, and we have seen a large jump in accuracy with the newer models. Okay, and then the next question is, and for server hosted or full precision local inference models. Server hosted or full precision local inference models. Yeah, I'm not sure if I'm going to answer this, so please chime in if I'm not. But you could definitely use your model if you wanted, and add more context that brings in the context of your organization. We had there were some security specific models that we use at Google, but we didn't find we needed those. But we did add context specifically in the prompt. We added it in the prompt, but you're welcome. We considered using RAG models, etc. But in the end, we did not do that. We put all the context in the prompt. I hope that answers, and feel free to chime in if I missed your question. Thank you. Grace, do you recommend any enterprise LLMs that could be a good starting point for risk assessment scoring? I'm a little biased, right? So I use Gemini LLMs. So that's what I use. I don't think it has, I don't really know about the other models. I think the best thing you could do is try it across different models and see if there's differences. There probably will be differences. So I would suggest to use to use the same query and use the same technique across different models, see what happens. And that's another good lesson learned, is that you could try to improve accuracy with a different model. Yeah. Okay, Marina, thanks for your question. Has data poisoning ever been an issue? How is it addressed? Okay. We we didn't really consider that. Our sources of info, I would say, are pretty secure, but like that could be, you're thinking like a cyber person. Certainly data poisoning could impact it. You have to remember, this is risk. This is around risk calculation, risk measurement, and understanding risk. It's not, I wouldn't say it will, if we're off by a little, I don't think it would have a huge impact. But that said, we didn't really think about data poisoning because our sources are internal sources, and hopefully those are pretty trusted. Yeah, thank you. Marielle asks, is there an open source platform for a free application you would recommend to start practicing creating an LLM for free? I don't know. That's the simple answer. I know that you can get, with the larger LLMs, they do have some freebie stuff. So you might want to consider that. Maybe someone on the call would suggest something, but the simple answer is I don't know. But that's good. Try experiment. I fully support that. Sanja asks, is there a risk taxonomy you could share? Okay, so I did share a few. So the one that's public, right, is the MITRE taxonomy, CWE 25. That's the top 25. I think they call it the most dangerous software vulnerabilities. That is software only, right? So that's something we used, to start with. And then we understood there were gaps with that because there was no hardware and it wasn't necessarily cloud specific. So we had to add our own additional things. So you might start with a taxonomy that's out there, but you also might add another taxonomy that's very specific to your org. Thank you. Okay, Wendy asks, what did your testing cycles look like to ensure compliance? So our whole attitude was that this was kind of a new thing. So we wanted to really ensure that the accuracy was there. Okay, so but so if it was up to us, we would have really top accuracy. And our first results were okay. They weren't great. They were okay with some tweaking and with some adjustments of the prompt and also adjustments of the model. They went really high up. So at that point, everyone was very confident that this was ready. But we did have to include, this is important because we did have to include our stakeholders, because they were really the ones to decide if this is okay, if it's accurate enough. Sometimes, you don't want to strive for perfection, right? Just good enough is better than nothing, right? So at least now there's more visibility. Yeah, we have an X% chance of it not classifying properly, but we're pretty confident, and we do have, the good thing is we do have that metric, we do have that measurement. So that really helps define the quality, and that really helped us get through all the testing and approvals. Thank you. Okay, another question is, this shouldn't replace human intelligence. I've used 3 LLMs to aggregate some data from 10 sources, and I got incorrect results. Correct, you're correct. It does. We do not think this will completely replace a security analyst, but just to keep in mind, we would have had to, in order to do the same amount of work, we would have had to hire a lot of folks, which would not happen, and do a lot of manual risk classifications, which are not as consistent. So you're right, it does not replace human. It replaces some of the manual things that potentially a security analyst could do, but now the security analyst can now do a little bit more deeper work. But I think that the point that you have, that it was incorrect. Uh, yes, you're right. The first shot. It's not gonna be as good. We found that we had 5 to 6 iterations, and then it started getting a lot better. So off the bat, don't be patient. Don't, I wouldn't dismiss it off the bat. If this is really important for you, try it with different prompting, different models, etc. Thank you. Okay, Julie asks, totally basic question. You can run through an example. Uh, yeah, I can't go too deep into specifics. But like multi-tenancy is an important risk in cloud security. And prior to our classification of multi-tenancy, well, across all our risks, we had no real visibility. We had like guesses, and people, thought, oh yeah, this is important. But now we're able to classify against all our documented risks, and now we're able to say we have X% of our risks are multi-tenant issues. So this is something that we would not be able to do otherwise, and often also multi-tenancy is not so simple to define. So having a human do that is not so feasible. But so now we have this viewpoint. We can also pinpoint a little bit more which products might be more exposed to it. So engage with them a little bit more. I hope that helps. Thank you. I love the questions. Thanks everyone. Sanja asks, how do you deal with interconnected risks for the processes that both use LLMs and not LLM data? So I'm not sure I understand this question, but the LLMs are for classification, right? So this is on a layer on top of the data you have, right? So it just gives you some more insight into the data. So I'm not quite sure I understand it. If you can reword it, I'm happy to answer it. Thank you. Joan asks, what extent do you incorporate behavioral conversation history into risk scoring? Have you encountered challenges with the model losing track of key information? No. That's the simple answer is no, because we run this automatically. It's not I should have maybe mentioned that. It's not like a chat interface. It's an automatic classification. So every time a risk comes, it's automatically classified by all these different classifiers. So there's no like long conversation, etc. It's like a batch job. It just a new risk comes in, it's classified. Okay, hope that helps. Carolyn's writes, could you briefly define what are considered hallucinations? Oh yeah. So we did have some hallucinations where it was making up classes. Well, it wasn't making up. It was probably even correct, but it didn't fit into one of the, let's say, 25 buckets, because maybe it was a hardware issue or something else. So it would sort of say, well, this really fits into this, and it wasn't one of our buckets. So in that sense, it was kind of hallucinating because it wasn't matching the outputs that we wanted. It also could, like for product names, since some of them are very hard to determine, because there's not so much information. If there's information, more information, sometimes the risk issue has the actual product name in there, then it's pretty easy for the LLMs to find. But oftentimes there's like either old names or some reference and very, not so direct information. So the LLMs might take like one little piece of that information that's given and just go off and say, oh, it's this product because of this. So it might go off, but then when we restrict it to a product catalog, then the hallucinations decreased. Thank you. Okay. This shouldn't replace human intelligence as I've used. Okay, I think we answered that. Um, yeah, thank you for that. Great. Thanks so much for all those questions. I really appreciate it. For those who want to reach out to me, I forgot to put it, but my email is sharoncrew@google.com. So my first name, last name at google.com. I'm, excited that you guys attended. I'm really happy. And I'll pass it off to Morgan. Okay. I'm just going to put my email in the chat. Oh, no, that's the wrong chat. Okay, I think I have to end slides. And Morgan,